All right, we're going to work with application problems for right triangle trig. So many applications of right triangle trig involve the angle with an imaginary horizontal line. So here is our imaginary horizontal line shown in this figure. And the line of sight to that object is called the angle of elevation. The angle formed by a horizontal line and the line of sight below it is called the angle of depression. So imagine here is a car and then there's a plane. This angle above it is called the angle of elevation to that line of sight from the airplane. And here's this person. Below it is called the angle of depression to maybe looking down at that car. So here's an example of an angle of elevation. Sighting the top of a building, a surveyor measured the angle of elevation to be 22 degrees. So here is the surveyor. Here is your building. And that line of sight is going up to the top of the building. Here is your horizontal line, creating a right triangle. And this angle of elevation is 22 degrees. The transit is 5 feet above the ground. And 300 feet from the building. So this distance here is 300 feet. We want to find the total height of this building. So we're going to do this in a couple steps. So we want to find side A first. So I'm going to go ahead and change colors here. I'm going to label the sides. So side opposite is our A. Side adjacent, we'll let that be, let's call that X. And then here is your side hypotenuse. And what we want to do is find this distance right here. So we're going to choose the appropriate trig function. So if you remember, so, ka, toa. We want to work with side opposite and adjacent. They should say adjacent here. So we're going to choose the tangent function. So the tangent of an angle is found by side opposite over adjacent. So let's sub in what we know. The angle is 22 degrees. Side opposite is unknown, side A. And then side adjacent, 300 feet. And we're going to solve for A. So we're going to multiply both sides by 300. And then we're going to type this into our calculator. The mode that we want to be in is degree mode. So this A value is approximately 121 feet. Now, that height of that part of the building above the transit is approximately 125 feet. But we need to add another 5 feet to the height of the total building. Because this transit, I can try and draw maybe a black line here, is right in here of 5 feet to give you the total height. So this height is length A plus that 5 feet more off the ground. So the height of the building is length A plus 5 feet. So that length A is 121 plus 5. So the height of the building is 126 feet. This next slide talks about your calculator. If two sides of a right triangle are known, an appropriate trig function can be used. You will need to use an inverse key to find the angle measure. So for example, the sine of theta is 0.866, and you want to find the angle measure. So you have to use the inverse key, which is labeled sine inverse. It is not the second button. So the graphing calculator is our choice that we like. So you're going to type in second, sine, and then 0.866, and then enter. And what you're going to get is an angle that is approximately 60 degrees. So if you're looking for an angle measure, you need to use the inverse key. So here's example 7. Determine the angle of elevation. So a building is 121 meters tall. So here's that height. And it casts a shadow of 25 meters. And we want to find the angle of elevation to the nearest degree for that sun. So I'm going to label the sides. 21 meters is side opposite. 25 meters is side adjacent. And then the hypotenuse is unknown. And we want to find this measure of this angle right here. So we have to choose the appropriate trig function. So I'm going to just write so, ka, and then toa. So which trig function works with side opposite and adjacent? Well, that's tangent. So I'm going to write that trig function down, the ratio. The tangent of an angle is side opposite over adjacent. And now sub in those values. So the tangent of the angle is unknown. Opposite is 21 meters. Adjacent, 25 meters. So we have a ratio. We want to find the measure of the angle, so we have to use inverse trig. So we're going to say theta equals the tangent inverse of 21/25. So if we want to find the degree measure, we want to make sure our mode of our calculator is in degree mode. So go ahead and pause, take out your calculator, and you're going to enter this in to your calculator. So if you're using a graphing calculator, you want to type second, tangent, then 21 divided by 25, and then enter. And what you're going to get is an angle that is approximately 40 degrees. Whoa! So that's what this angle is right here.